This webinar will be recorded, and recording can be found later on the webpage of Nordic Sustainable Construction. My name is Marja Tiainen, and I work as a senior specialist at the Ministry of the Environment in Finland. I am the project owner and leading this project from our part. This is actually the second webinar of this project, though we already have had several other webinars which were about the other subtask of this work package. Also, those recordings and the materials can be found on the webpage of Nordic Sustainable Construction. Before we start the actual content of this webinar, I will shortly say a couple of words of the whole work package and also who is behind it. Nordic Sustainable Construction is a program under the Nordic Council of Ministers, which contributes to the Nordic Vision 2030 of becoming a sustainable and integrated region by 2030 in respect to sustainable construction and housing. Purpose of the program is to accelerate the knowledge and capacity for a green transition in the Nordic construction sector, strengthen Nordic collaboration, and also ensure an aligned Nordic path. The program is organized into the following 5 work packages, working with the specific area of sustainable construction. We have Nordic harmonization of life cycle assessment, circular business models and procurement, sustainable construction materials and architecture, emission-free construction sites, and program secretariat and competence for reusing construction. And this project and webinar belongs to the first one, so Nordic harmonization of life cycle assessment. In this work package, we have 5 different subtasks. I mean, this Nordic harmonization life cycle assessment. And the aim of this work package is to work towards harmonization and normative methods for building LCAs in the Nordic countries. Similar approaches will surely benefit construction industry and policymakers on national and municipal levels so that we can support each other's climate ambitions in regulations and in green public procurements, but also in the European policy development. And here in the picture, you can see the different 5 subtasks that belong to these work packages. So we have task 1, Nordic LCA practices. We have task 2, database and scenarios. Task 3, digitalization of LCA, and task 4, limit values. And task 5, acceleration program. The first one, so the 1 to 4 have been finalized. 2, 3, and 4 have been finalized this year. The task 1 a little bit earlier, and the final task 5, the acceleration project, will be finalized this year. And today we will hear more about the acceleration project and one of its subtasks. And actually the target of this acceleration program is to accelerate the low carbonization of building sector and support building project in aiming at lesser emissions. Thank you, and I will give floor to the project members presenting this work package or subtask 5 of the work package 1. So, Nikolai, and you can take a floor yes. Or Kiki.
Yes, thank you very much. I will be taking the floor first. Just one moment. I just need to share my screen so you can see some slides here. Starting with the first slide, of course. Sorry. Yes, So welcome to the launch webinar of this, what we call the best practice catalog, which is a building LCA catalog with cases from the Nordic countries and Estonia. I will be repeating a little bit what Maria said, but then I also hope it's very clear what this is all about. And then after I have spoken a little bit, Kiki from Aalborg University will take over and go deeper into the findings that we've had in this project. So yes, and I will just jump to the next. Yes, as Maria mentioned, this work is part of the Nordic Sustainable Construction Program, which is funded by the Nordic Council of Ministers. And it has been structured in these 5 work packages that Maria just presented. And it has been running for 3 years and was recently finalized and wrapped up at a Nordic Sustainable Construction Symposium, which you can also find on their website. And there are some really interesting projects and reports that has been published during these 3 years. So go in and have a look. And the project that we're presenting today is part of this work package 1, and it's called Task 5. So it's the acceleration program. And yeah, as you just heard, the work package 1 consisted of several tasks, all with the goal of investigating possibilities and challenges with harmonization of LCA in the Nordic countries and Estonia. So we've had these LCA practices, data, calculating with digital models, limit values, monitoring decarbonization, regulatory needs for harmonizing has all been studied, and it's a lot of interesting reports on this. And task 5, which we are presenting today, is this acceleration program. So task 5 is also again divided into 2 subtasks, so it's a subtask again, but we've divided it, it was divided into these 2, 5.1 and 5.2. 5.1 being the knowledge sharing clinics or low carbon clinics. We will present a little teaser of what this is today, but this is not the main launch today. The main launch is task 5.2, which is this best practice catalog. And so the overall purpose with the task 5 is to kind of speed up this decarbonization of the building and construction sector through knowledge sharing. A lot of companies across the Nordics are in different phases in setting and implementing low carbon solutions. And in many cases, external support is needed to set these sustainability targets or to work with low carbon solutions. In addition to this, best practice and examples of low carbon buildings are also needed to accelerate decarbonization. So this is what we will be sharing today. So the team behind task 5 is actually also the same team that did task 4, if anybody has looked into that, but it was consisted of a lot of Sweco countries. So Sweco from Denmark, Sweden, Norway, and Finland. Then we had Build, Aalborg University from Denmark also. We had EFLA from Iceland and LCA support from Estonia on the team. And my name is Nikolaj. I'm from Sweco, Denmark, and next to me is Rikke, and we've had the project management role for this project. So just a little teaser before we go deep into task 5.2, a little teaser for task 5.1, which is also launching very soon. So the aim of task 5.1 was to increase the know-how in the market through what we call these low carbon clinics. The clinics consisted of some workshops, some follow-ups with some clients that had, what can you say, actual real life problems or solutions to decarbonizing. So the team behind Task 5, which I just presented, has been working as external sustainability resources to these clients, and we helped the clients by discussing and proposing improvements to the environmental sustainability of these projects. And we ended up with having 11 clinics across these Nordic countries and Estonia. And it was with projects in various building phases, and also with clients who had various experience with implementing sustainability targets and low carbon solutions. So it's really interesting work, and it's as I said, it was kind of a teaser because we're just finalizing this report, and it will be launched at a similar webinar to this on January 23rd. I don't have a direct sign-up link yet. I think it will be posted maybe tomorrow, but follow Nordic Sustainable Construction's website or follow them on LinkedIn, and you will be sure not to miss the sign-up link for this launch also. Then we'll just jump into talking a little bit about Task 5.2, and then Kiki will go more in depth. So in Task 5.2, the job was to draft this catalogue of low carbon buildings in each of the Nordic countries and Estonia. And we had a requirement which was to include at least 3 building projects from each country to ensure inclusion and a broad perspective on the current state of the art in the Nordic region. So we gathered and evaluated projects to ensure various typologies also, and various low carbon solutions. And the catalog then also explains the low carbon solutions in these different projects, and reflects on how the solutions can be used. Then just shortly about the timeline. We started this project approximately half a year ago in June, where we had a first webinar, which you can also find on the webpage. This was where we launched the sign-up links for both of these tasks. So Task 5.2, the clinics, and 5.1, the clinics, and 5.2, the catalog. We used our own network, of course, and also LinkedIn and so on to promote this sign up. So we've tried to kind of reach out for project owners or contractors or whoever the client could be, to sign up their projects for this very, as we see it at least, very important knowledge sharing platform. And then we had kind of like a sign-up period, which went through like the summer and also the summer holiday. So July and August, we had this both like sign-up period and a project selection period, which was going kind of simultaneously. And then in September, we had to like evaluate finally which project had to go into the catalog, and then we did, like in September, October, and November, we did a lot of data gathering and data processing, and in November and December we have focused our work on getting the catalog together and having it published. And what was interesting here was actually the data gathering process seemed to be a bit more complex than we expected. And this was mainly due to the differences in available data. And actually, maybe it kind of shows quite well how the LCA data landscape is not really harmonized at the moment. So that was, I mean, a valuable learning experience here. Then just shortly what we ended up with before Kiki will take the floor. We ended up with a catalog consisting of 4 projects from Denmark, 2 from Estonia. We didn't reach the target of 3, 4 from Finland, 4 from Iceland, 6 from Norway, and 6 from Sweden. And as you see here in the bottom, there is a link to the report, and it should also be, this is how the report look online, and that is the front page. And you can go and explore these 26 cases we have after the webinar. And if we're just sitting here waving our hands, it's because the light has gone out, sorry. That was it from me. We will take questions in the end. So let me know in the end if you have any questions for my part. Otherwise, I will leave the floor to Kiki to go more in depth with the findings in this catalog.
Yes, thank you. I will just the obligatory sharing my slides. Yes, so I hope you can see it soon. There's a bit of a delay here. There we go. So me and some of my colleagues here at Build have been quite busy the last couple of months here, putting analyzing the data and putting this catalog together. And I'm going to present some of the LCA results that we show for each of the cases that we found in the catalog, and also a bit about the variation in method and some of the approaches or carbon mitigation measures that were used in the cases that we were able to get. So, diving right in, these are the distribution of the building types that we got overall. And in total, if you were quick to calculate in the previous slide that Nikolai showed you, you would know. But there are 26 cases in the catalog. And, well, most of these cases are new construction. And also, as you can see here, there's a lot of residential buildings, but there's also different types, commercial buildings, logistical, schools, office, and so on. There are a few, I think 2 or maybe 3 that are renovation cases, but the rest are new. And in the catalog, I'm not going to show you this, I'm just going to tell you, in the catalog, we start off each case by showing you some nice pictures and a description and some details about each project. So you have sort of the context, and also like a description of the carbon mitigation measures. Sorry, it's a hard word to say today, that were applied. And then we show the LCA results. And now I will show you what LCA results we then show for each of the cases. There we go. First of all, we show the total global warming potential split into these life cycle modules or life cycle stages, some people also call it, so that you can get an overview of that. And we show it in the unit kilogram CO2 equivalent per square meter reference area per year. I know for some this unit might be a bit weird, but that was what was chosen to use. So that is what you'll see. Then we also show a figure of, sorry, I got lost in my notes. We also show a figure of what type of emissions these are. Again, it's the total GWP, but then split into what goes to materials and what goes to operation. And also, we show this nice figure here to say something about when does the emissions occur. Again, it's the total GWP, but then split into upfront carbon. That means the emissions happening from materials and construction of the building, but also future scenarios, or what we in the figure just call scenarios. That is emissions that will occur after the building has started to be used, and that is dependent on some sort of scenario happening. We also show the D phase. This is shown separately because it's usually outside the system boundary, and it is potential benefits from for example, reuse or recycling. But that is what we show here. Then we dive a bit more into the impacts from materials. So this figure show the GVP for related only to material use or the building elements, and it's split into the different building components you can see here, so that you can see which is the most or least contributing building component or building element in that particular case. And here we don't show the result per year. It's simply a kilogram CO2 equivalent per reference area. Then we stay with the building elements again, but then we show you the sort of carbon intensity of that building element, so GVP per kilogram of building element, compared to how much does the element weighs in relation to the reference area. So that, as you can see for this case that I show here, there is not always a correlation between the carbon intensity and the weight. In this case, it's quite the opposite, actually. And it might be quite interesting to see. Then we show sort of the same thing as the figure showed you before, but for the building materials. So for the 10 building materials used with the highest GVP, so sort of the hotspots, or how to say, we show again the carbon intensity versus the weight of that material per reference area. And again, there is not always a correlation between this carbon intensity and weight of the material. Now, moving on. As I said in the beginning, I will talk to you about some of the variation in method that are used to obtain these LCA results in the different cases. And I'm going to spend some time on this. If you found it boring, I'm sorry. But all of the results, of course, have been obtained based on an LCA. However, there are some variation in the method. And this means that you should be very careful in comparing results across the cases and always keep these variations in mind. That we have done stuff in the catalog to help you with this, don't worry. I will show that later. And some of the variations that there are more variations than I show right here, but these are just the ones that I thought would be interesting to show. Now, there's a variation in which and how many modules that are included, or life cycle stages, which building components or elements are included or excluded. And other variations in methods include GVP indicator, the climate impact data, or background data, as we call it, whether or not they use decarbonization scenarios, and how to handle exported energy. I will go into detail with all of this in the coming slides. But first of all, as I said, in the catalog, before we show you all the cases, we have this table to give an overview of the method that are used in the different cases. So, as I said, modules included, which elements are excluded, and so on. So this can help give an overview of the variation in method. Also, before presenting the LCA results for each of the cases, we have a short table showing the assessment methods used. So hopefully you should be able to both with this table and with the information given in the beginning before the LCA results in each case. You should be able to get a good grasp on the method. Like on an overview, of course, it's not a deep dive into the method. It's not that kind of task, but it should give an overview of that. Now, moving on to some of those variations that I mentioned before. First of all, we have the included modules. And this figure that I show here shows how many cases, remember there were 26 in total, how many cases include which life cycle stages or modules, so to say. And what we can see here is, first of all, that all of the cases include phase A1 to A3, so raw material supply, transport, and manufacturing of the building products or material that are put in. And they all include replacement of building material during the use of the building. They all, with one exception, also include operational energy, energy use. That one case that you can see is missing. It's not because it doesn't actually include it. It was just because it was a bit of a special case, so we couldn't really get the information. But in reality, it includes it. We just couldn't include it here in the catalog. So those are the ones that are often included. And you can also see that the construction stage and transport and the construction process is included in many cases, not all, but in many cases. And the same with waste processing and disposal at end of life. Now, I don't have nice circles around that, but the phases B1 to B3 is not included in many cases. Actually, I think maybe only in one. There is one project that you'll see that includes everything from A1 to D. But that's also a bit of a special case because this project or case was a part of a PhD project, and there's therefore a lot of nice analysis and things on that particular case. So this is why this one includes all the building modules that you'll see. Yeah, that was that for this one. Then we have the variation in including building elements. And this figure shows how many cases exclude these certain building elements. And what we can see from the bottom four things that are excluded, internal, external finishes, internal doors, and external doors and windows, is that there are very few cases that exclude this. So this actually means that most of the cases include all main construction material and elements in the case, which is a nice thing, I think. Also, you can see here, oh yeah, I forgot to mention that if you notice that there aren't really 26 cases here in this figure, that's because there were two cases where we didn't have the information needed to say which building elements are excluded. So there are only sort of 24 cases represented here, unfortunately. But all cases, that means 24 cases in terms of all, exclude fixed furniture. So apparently that's not something that any of us wants to include, at least not right now. Roughly half of the projects exclude building services. And this is actually quite interesting and something to keep in mind, because building services can actually have quite an impact when included or excluded on the overall results. Yeah, for instance, if you have solar cells in the building and you include it in your energy calculation, like you get the benefits in phase B6, but you don't include it as a building material in your model, that can have an effect. But also all the others for heating and ventilation systems and so on. Also, you can see that, sorry, got distracted for a minute. You can see that a lot of the projects or cases actually exclude specialist groundworks and piling. And that's maybe not so surprising, at least not to me, actually, because it's not really needed in all cases. In some cases, it's just you need a foundation and then everything is good. You don't need more than that. So that might be because so many that, sorry, I'll start over in that sentence. So that might be why so many cases don't include this, because it simply isn't needed. Now, moving on to the other variations in the method that we could see. First of all, there is the GVP indicator. So what we show all the results in, that actually also varies. And it comes down to, this is biogenic carbon included, which is in GVP total, or is it not included, which it is in the other category. And I think it's on a country level. So some of the countries we have cases from include biogenic carbon and use this GVP total, and the other have don't. So also keep this in mind when you read the results, that some is with biogenic carbon and some is without. Also, the climate impact data, or the background data that is used, I mean, all of the cases use sort of a mix between product-specific EPDs from national industry associations, and generic environmental data, country-specific generic data. But we didn't have the information, or we didn't have the time. It wasn't really within the scope of this project to sort of gather the information on what the distribution was between these data sources and stuff. So therefore, we didn't include information on this. So there isn't really any information on, is everything based on EPDs, or is everything based on generic data? Because often generic data can be a bit more conservative than EPDs. So also keep this in mind, that there isn't really any information about this in the catalog, unfortunately. Then there is this decarbonization scenarios of energy. And yeah, that is, of course, used to estimate B6, the operational energy use. And what it basically is, do we include considerations or scenarios for the fact that the energy grid becomes greener? And several of the methods include this gradual decarbonization of the energy grid. However, they do it in different ways, and it have also been a bit difficult for us in some cases to actually see through what exactly is happening with this decarbonization. So again, just keep it in mind that this varies from case to case, what is used here, and if it is even used, these scenarios. The same goes for decarbonization of materials. This is, for instance, relevant for B4, like replacement, because materials can, in the future be produced from cleaner energy, or the method have been optimized in order to produce it. So if we replace something in the future, it might not have the same impact as we do now. And there's one of the methods, future build, that actually incorporates scenarios for this, but the rest doesn't. And I think, I'm going to be careful here, but I think the only cases that use this future build are the ones from Norway, actually. Yeah, my colleague is nodding beside me. So yeah, I didn't say too much. Yes, and finally, we have the whole issue with exported energy. So if again, if you use solar cells and we have a surplus of energy, we produce more than we need, then of course you can send it to the energy grid. And well, how is that dealt with, that you want to send it to the energy grid? Currently, there are different approaches across different certification systems, different regulations, and there are also various things to consider here. That how do we allocate these potential savings and stuff. So that is the final thing to keep in mind when looking at the results, that this is also something that varies quite a lot. And now I think we've heard enough about the variation methods, so I will move on to maybe some of the more fun stuff, which is the different decarbonization or carbon mitigation measures strategies that we were able to identify from these 26 cases. Now, here are the 7 or 8, if you will, if you count the other strategy, sort of carbon mitigation measures that we were able to identify from the information that we had. And there are, some of these might look very familiar to you guys. I guess many of them will. It's using bio-based materials, more material efficient design and renewable energy system and so on. And I will go into detail in a few slides with this other measures category, because it's a bit broad what it includes. Yeah. And in the catalog, after we've shown you all the cases, gone through all this, we have a section called cross-case analysis. And in that section, there's a table to give you an overview of all these different measures and how that specific case apply this measure, because it can be, this is just an overall, the headline, bio-based materials, for instance, but it can be many things. It can be applied in many ways. So that is identified. And I'll just jump right into showing you a small section of this table, and where we, of course, relates to what case is it. I'm sorry if it's a bit small, but yeah. Of course, identify which case are we talking about, the sort of overall carbon mitigation measure that were applied. And we use these nice symbols for easy identification of which strategy or a measure is used. The places where there are no symbol, that is this other, is in the bottom here. I don't know if I can show you. I don't know if you see my mouse, but anyways, it's in the bottom. And then also we, as I said before, have a small description, not in depth. You can go to the specific case to see that, but sort of how is this carbon mitigation measure dealt with in that particular case. Yeah. And now I will just show you a few examples of these carbon mitigation measures. No, I wouldn't. I'm going to show you some general information first. Sorry. I forgot. So here are the 8 different carbon mitigation methods, and this figure shows how many cases apply that specific measure. And as you can see, it's quite an even distribution, so to say. A lot of cases use these different measures. The only 2 that are not used that much, or the only one that's not used that much actually, is transport supply chain. But otherwise, it's used fairly evenly between the cases. Another interesting thing, at least I think, is that the cases use more than one mitigation measure. And here you can see how many measures, again, of the ones that we were able to identify through the information that were given to us. That a few, and keep in mind here that there are 8 different measures in total, if you include that other category. And yeah, so again, a lot of the cases actually uses multiple different mitigation measures, and a few, of course, uses one, but many uses a lot of different strategies or measures. And now I'm going to show you some examples of these. I'm going to show you some examples of the material efficient design, because I actually found that that's one of the strategies or measure that has many different forms. When you look at the different cases, it can be many different specific things. And also I'm going to dive into that other category there. So the material efficient design, what does that mean, at least in the cases? For different building types, it can be used of a specific certification program, in this case, the Future Build program, because it has a focus on reducing CO2 from energy and materials. It can also be, in this case, it's a logistical building, and it can mean use of specific, building elements in order to sort of optimize and use the materials most efficiently. In this case, it's a sheet metal sandwich wall element and some concrete slab that were used in order to sort of optimize the material use, sort of to use less material. Let's say that. I got into that a bit backwards, I'm sorry. Here we go. Also, there are 2 different low residential buildings or one-family houses that take this optimization sort of from 2 different ways. One is that looking at key elements and then optimizing those, so minimal amount of material is used. And another one-family house looking sort of at, take one material that you know has a low carbon impact, and then you optimize the entire building design for use of that particular material. Also, another case again, looked at this strategy to prioritizing low-tech solutions, so solutions that you are sort of, that are low-tech, and also the use of multifunctional spaces, so that you don't need to adapt the building and modify it in the future, because it's already thought in to these areas that they can be adapted easily, or they can be used in multiple ways from the beginning. And finally, we have an office building that uses, and this is quite interesting, I think, because, I mean, at least in my experience, office buildings are often changed quite a lot. It's you want a new meeting room or some new tenants or whatnot, so it's changed quite a lot. So this office building used this flexible layout design so that to allow that you can modify the space quite easily. Also, they use this thing, modular dimensions for installations, with something I've never seen this before. Quite interesting, to sort of ensure that material are used most optimally, but also that things can easily be adapted in the future, so that the installation doesn't go in the way. And then they also use sort of a slimmed down structure, so they optimize the structure as much as possible. And then final thing, we have this other measures category that focus on different things. And one of the things that I found in this, sorry, and I won't, there we go, is energy. So sort of to use energy efficient design green roofs to reduce the need for cooling, urban heat island effects, sort of focusing on designing so that operational energy use is reduced, or yeah. Then another topic in this other category is ventilation. And here there were some projects that sort of focused on using passive or natural ventilation, and through sort of the design of the building itself, or through placing windows and opening in the building so that air could flow more naturally, and by that way saving in CO2 because you didn't need energy. Yep. Then there's also this sort of category where you monitor monitor or control the sort of energy use throughout the building. And finally, there is this, in the other category, this integration of LCA or impact evaluation, sort of ongoing after the project has been finished, or also both ongoing afterwards or early in the design stage or early in the process, in order to sort of identify where things are needed. And that was all from me, actually. Hope you got something out of that, and thank you.
Thank you very much, Kiki. We now have approximately 10 minutes for a Q&A. And so please either write something in the chat, and we will. I see that we have already had a couple of questions that we already answered in the chat. Otherwise, you can also raise your hand, and we will pick you out, and we will see who can answer. Either it will be me and Rikke, or probably it will be Kiki. And I believe, Kiki, you have your colleague Kai maybe next to you.
Yep, he is.
Yeah. So let us know if you have any questions. We have one question at least that hasn't been answered, whether we could share the link for the catalog. And I have a link for the catalog in the slides, and I believe the slides will be shared. Correct, Marcus? I believe you will be sharing the slides.
Be sharing the slides afterwards, and also the recordings from this webinar. And also gonna include a link to the sign up for the other webinar in January that you mentioned earlier. So yeah.
So a lot of.
We'll make sure you get all the information. Yeah. Yeah.
Great. So are there any questions for the cases or the cross-case analysis or anything? Or are you just ready to dive into the catalog and
I'll dive into lunch.
There is a question for you, Kiki. How do you see that CLT the next 10 years will develop? Be way more or less?
I'm curious.
Yeah, well, that's a big question. I don't know if I'm the right person to answer that. Yeah, I don't know. I mean, it's a way, I guess, to sort of use wood in places where you cannot, because it's engineered and because it has better structural abilities, it's a way to use it in places where you can't use sawn wood or these other treated wood products. So that could sort of mean that it's used more. But I honestly don't know. I mean, we are moving at least towards more and more use of biogenic or bio-based materials. So this could be a thing. Of course, there are issues with this whole at least in Denmark, I don't know how the rules are elsewhere, but this whole fire and moisture, they can't manage as much as these traditional mineral-based materials. But I think it is sort of the way it's moving, to be honest. Of course, there's stuff to be solved along the way to ensure that we don't everything go up in flames or everything rots away. But yeah, I think it will move that way to more. I don't know if you have anything, Kai.
Yeah, I would like just a big question, but why we see the CLT and other biogenic material structures and materials used is because there's a regulatory demand. I also have my camera. Okay. The regulatory demand, and I think when this is evolving, and also it is decided on EU level there would be carbon limits. All EU countries from 2030. I guess we will see much more timber construction, and CT specifically will compete for what is best to deliver. So I guess we see much more of it. But currently it requires very specialized manufacturing value chains, as you know, and this is not happening overnight, and the capacity is not scaled overnight. So it will take time, but hopefully we all can help to harmonize the regulatory demands so that there's a safety for investments into these capacities. Circularity, if I just may, about the circularity. I guess we have not had the material to justify circular measures, and it's also you can see reflected in the current process of method development, where circularity is not integrated well enough. I know there are a lot of development projects, and we also work on that. So that would be all again necessary, that the regulatory and the standardization, which is ongoing at the moment, creates a safe and transparent environment for these innovations to be demanded. But in this project there was no circularity measures.
And Kiki, you mentioned there was just this question about whether you could elaborate on the comments on fire and moisture, and maybe, I mean, there are many more issues with building with the bio-based or CLT. At least there's also acoustics and all this. At least when we are in Denmark, some places it's different. But maybe you could elaborate what are the actual issues or problems right now.
Yeah, I mean, I was speaking from a Danish point of view with that, because I mean, in the Danish regulations right now, at least in terms of fire, you cannot just use wood products, at least not when you build in higher buildings, because you need to cover them with something that can't burn. And then you use wood, yeah, but you also use more material because you have to cover it, or then you have to use wood in maybe in different ways, or CLT for different purposes. So that's sort of the issue right now. And with moisture, it's I was just involved in another project, so that's why I mention it, that especially with bathrooms or wet rooms, you need to sort of make sure that the moisture don't go to the structure, and it can be a bit more tricky in CLT buildings or wooden buildings in general, because she said they move more than mineral building, concrete buildings, for instance, and they also are more, what's the word, susceptible to temperature change, and so the material expand and contract a bit, and that makes it harder to sort of ensure that water cannot come into the structure and And they're also, of course, more challenged with the fact that this is a biodegradable material. So if water comes and if moisture is there for a long time, larger damage might happen than in mineral materials. But of course, this is something that I know that at least here in Denmark we're working on, sort of because we want to build more. So that was what I meant by fire and moisture and so on. Yeah.
So right now it's basically regulations that are
regulations and traditions, or what you should call it. How do we usually build? And that is a tough one to change sometimes.
Yeah, but we did not delve into this in this project. No. So this is collecting cases and disseminating them. But there are tons of other projects working with this, and including in Denmark and probably also in other countries, a revision of the current building regulations in order to accommodate a more biogenic and low carbon construction methods.
Yes, I think we will take maybe one last question here, because we only have 2 minutes. About the renovation cases. Were there any risks during the renovation process? Do the risks impact changes in decisions and affect the LCA results?
We did not look into renovation processes in a detailed manner.
And one of the projects was also like a pilot project. It was quite special because it was of what's called listed building. It's called that. When it's like you cannot tear it down. It's like it has historical value. But no, we didn't look into it at all.
Okay.
No.
And let's take the last question then from Flemming here. Good and healthy forestry is a theme, I guess, also with the whole IKEA documentary in Denmark at least. How can we ensure healthy forestry if we switch to wooden structures?
Again, this is way question. Beyond the scope. But there's research and development ongoing also here at Build. Because as timber and biogenic materials are going to take more space and consume more land area, we have to look at this. There is also a political wish in Denmark and the EU to also couple the biodiversity analysis on this decarbonization of the built environment, which is a necessary control mechanism. This is obviously something which goes way back in the value chain for construction, and not only construction. And there are a lot of mechanisms and regulations necessary in order to secure that we don't devastate forests for building green. But this is not something we could cover in this project. So
it's a bit out of scope, but thank you for the question anyway. I think we are out of time now. So thank you very much for all the questions. And as we just mentioned before, we will be sharing the slides and everything. So thank you for now.
Yeah.
Thank you.
Thank you, guys.
Thank you. Bye.
Thank you.
Bye.
Thank you.
Bye.
Bye.
Thank you. Bye.